Good. So abstract data types, right? Before going into linked lists or any other topic we discuss in the remaining of this course, which by the way is just we are going to touch the surface. You guys have 2SI, I guess, for data structures. That is after this course. So you'll cover these topics in details. But rather, I'd like you to understand the main concept, rather than going into the details of a linked list or a stack or a queue or whatever we're going to hear later. I would like you to understand the concept itself, because the concept also is an extension of our understanding of the mindset of object-oriented programming. Remember, especially in our last lecture, we had interfaces and abstract classes, right? You can think of like the name kind of very similar. We have abstract classes, and today we are talking about abstract data types. What is abstract thing? Generally, away from programming, abstraction is it's considered one of the highest degree of intelligence by humans, right? Being able to abstract something that is considered a high intelligence remark. Why? Because you have one use case. Okay, I'm going to observe this use case, do whatever you need to do, right? Let's say we're talking about like normal real life. You go through one situation and then you behave in a certain way and then you are done. And then a year later, you encounter a similar but slightly different situation. As a human, your mind is able to extract or abstract the first situation to apply your experience to the second one, right? Animals are not like this. And by the way, machine learning is not like this. One of the big differences or obstacles that we have right now in machine learning is how, as a human, you are able to abstract the information you gain. As a child, if you give a child like a picture of a cat in a certain position, like they look into a cat, for example, from the front, they are able to highlight cats afterwards. It's from the side or a different color or different shape or different type. They are able to know this. Why? Because their minds, our minds, are able to abstract the information we gain from a certain situation, apply it to different situations. For machine learning, you have to feed millions of pictures of cats. And then at the end, if you give it like a different picture, it will tell you that it's a dog, right? Something like that. So abstraction is very important. And being able to abstract is something that you need to learn while being in your undergraduate degree of engineering, because it's also a very important skill for engineers. Good? So this is like a side topic of why we are discussing abstraction. In programming, abstraction is even more important because many of the problems that are being solved in real life are dependent on your ability to apply other use cases. This is why we have abstraction data type, or ADT. Instead of focusing on solving one problem, we provide general solutions, generic ones, what we call abstract data types. And then, when you encounter a problem, the first thing you think of, instead of trying to come up with a totally new solution for this problem, you try to apply your own abstract data types, learned once, to the new problem. And now it's easier to solve. Good? This is the main idea behind abstract data types, or even object-oriented programming. Being able to separate between the abstraction of the type or the interface and the actual implementation. Is that clear? Good. To give you one example that you guys all know, arrays, right? We have dealt with arrays in C and in Java as well. If you think of an array from the programming point of view, it's just a list of elements all of the same type, and then you know how to write it in the correct syntax in C and Java. But array is just a way to implement a list of things, right? This is the abstract data type. You want to associate a certain relation between multiple variables. So that the main difference between an array and any other type is now you have multiple variables, multiple values that are connected together in a certain relation. And the relation itself is the abstraction thing, right? Which is a list of elements that are connected using a certain thing. In an array, all are the same type. And then based on the implementation of an array, these are implementation-specific things. It has nothing to do with the abstraction. All are initialized in the memory contiguously, right? And then all have to be the same type. But generally, a list of things, they don't have to be the same type, right? And they don't have to be contiguous in memory. Good? So taking this to linked lists, you can think of a linked list as a different way to implement a list of things with different conditions than arrays, right? You can think of an array as just a data structure, which is, it's actually, array is a data structure, right? We don't say We didn't say this before because you guys didn't know what is a data structure, what is abstraction types, but this is the reality. An array is a data type, an array is a data structure that is used to implement an abstract data type that is called list. Good? Is that clear? Is there anything that seems confusing? Good? So understanding this, I don't know how to emphasize this, but you don't know how important this to understand. Maybe out of the course, this is a single thing that I'm sure you will need some time, right? Like after 5 years, after 10 years, no matter what is your career, abstraction data types, data structures, and algorithms you are going to use no matter what, right? It's used in physics, VLSI, purely hardware, and it's also used in servers and in parallel programming. It's used in all stack of engineers, right? You need to understand this. If you have any question, ask, right? Good? If you understand this, then the remaining part is just discussing it in more details with some examples, and we are going to cover some data structures. Good? So, data types. We have dealt with data types before. Like int is a data type, double is a data type, float is a data type, right? So we have these, what we call primitive data types of a language. Good? But we also have data types that we defined ourselves. We said before a class is just a data type. Structures in C is a data type that you create yourself, right? So what is the main difference between the primitive data types of a language and a data type you define yourself? And what you need to do to define a data type, right? So if you define a data type, let's think of the primitive ones, because these are easy ones, an int, right? Integer variables. What does it mean? By just saying a variable is int, then you assign certain values to this variable, right? For example, it cannot be 2.5. This is not an int, right? So by just saying a variable is of a type int, then you limit the number of values that this variable can get. It has to be integer, for example, in this case, right? And then it has to be, if it's 32 bits, it has to be between 2 to the power 32 or 2 to the power 31 if it's negative, and then negative 2 to the power 31, right? So you have certain values that this variable is allowed to get, not other variables. This is not other values. This is the first thing you define when you define a certain data type. The second thing is, what are the type of operations that are allowed for integers, right? So for some variables or some data types, there are operations that are not allowed, right? And then for ints, for example, you are able to do division, addition, subtraction. So you know what are the set of operations you can perform on a variable of a certain data type. These are the two main things you need to define when you define a data type. Good? Great. So these are the primitive ones. What about classes? We said classes are our own data types, but do we ever define these two things? Is the values that are allowed to be assigned to the data type and the operations that are performed in this data type. What do you think? You guys have defined multiple classes before. And I told you now that a class is a data type. Good? And then I said a data type has to have these two characteristics. It defines the values that the variables of this data type can get, and the second thing is the type of operations that you can perform in this data type. What do you think? Did we do these two things? Yep. Can you raise your voice? Methods, yes. Methods is what? I kind of think that you are saying methods are the operations we do in a class. Is that correct? Yes, that's correct. So by defining certain methods, methods are the actions or the operations that you can do in a certain class, right? So if you think of a method is nothing other than an operator you can apply, right? So that's correct. What about the first thing, which is the set of values that are allowed for this data type? Someone else? If we define a class, yes. Yes, so field members are telling you the values that you can assign to this class that you are saying, right? Yeah, this is partially correct, so that's correct, right? So by defining a class, you define member variables and you define methods. We have discussed this before in the example of a dog, right? We said you have certain features, certain characteristics which are defined in your instance fields. Then you have a certain number of actions that you can take on the class. We have the example of a run, bark, right? Doing these things for a dog, which are operations that the class can do, right? So this is basically what we do in any class. You define member variables, you define methods to execute in this class, right? Which are, what are the values that are allowed for your data type, and what are the operations you can do in your data type. Good? The other thing is, you also define, based on the set of values, you define how much storage you need in memory. Good? For example, and we said this before, int is like 32-bit. Boolean is just 1 byte in C, but 16-bit in Java. Double, you have 64-bit. Float is 32-bit, right? So by just saying a data type, you know how much storage you need in the memory. What about classes? Based on a class, we know how many member variables we have and the methods, and then we allocate a place in memory. We know that by instantiating an object of a class, you actually create a place in the memory, and then the name of the object is a reference or a pointer to that place in memory, right? So by just saying a class name, you know how many members of that class and how much storage you need in the memory. Good? Is there any question? Yeah? This depends on, we use stack for this method, and then this depends on the number of input parameters. If we have time in the course, maybe the last lecture or 2 lectures, we'll discuss stacks, and we'll see how functions are being actually stored in a memory to execute a certain thing, right? But it's known, right? So you know how much you need for that, right? Whether known as a maximum that you need, you serve this, whether you use it or not, or it's known statically based on the type of the method. But you know how much storage you need. Good? Okay. We already discussed this. We already discussed the primitive ones. Good. We said classes is nothing other than a data type. You define yourself by defining the set of values, the methods or operations, and then how much storage you need in memory. And then here, I said this last lecture, but maybe many of you didn't get it. I told you this is not allowed in Java, but this is allowed in other languages, right? You can even overload. We discussed method overloading, right? What is method overloading? Yeah? Yeah, exactly. What about method overriding? What is method overriding? Someone else? Someone else? Yep. Back, like, yeah? Same name and same input parameters, right? And this happens usually in inheritance if you have a child class and a parent class. Thank you. So these are method overloading and overriding, which is like, in a sense, you are able to have multiple implementations of a method. And if you already have a method, you are able to override the implementation of this method, give it a new meaning, right? In Java, what I'm going to say right now is not allowed, but it's allowed in other languages, like in C, for example. And I said this last lecture. For example, the assignment operator, or the addition operator, or the subtraction operator, this is considered by the language as just a function, or in Java language is a method, which you are able also to override. What do I mean by this? For example, to add, you have to have 2 numbers at both sides, right? X plus y, then x has to be a float or a double or an int, and then the other way, x like a float or double or int or boolean in C, right? Great. But what if I'm adding a data structure, something like structures in C, to another structure? Is that allowed? This is not allowed. You cannot add 2 structures together. If you go back to our last lecture in C, we said the operations that are allowed in structures, not among them addition. But in fact, you can overload the addition operator to allow it to add 2 data structures. Like in C cases, it's a structure, right? How can we do this? Because addition or an operator or a type of operation is nothing other than really a function that takes input parameters, do a certain operation, return something, right? So methods are in fact very similar to the operations you can perform in a certain data type, right? Because in a method you take inputs, you perform a certain operation, and then you return something, right? You can write a method that's called sum, takes two input variables and then add it and then return the sum, right? Or multiplication on the same thing. Good. The difference here is you can call this method add by just add, right? Or subtract or something. Good. Good. So these methods are just operators. And then, yeah, one example, this kind of motivates why we need abstract data types. Good. So assume I want to, and you guys have this in lab 5, assume I want to insert something to a list. Good. I have already a list, and then I want to insert another member to this list. In our quiz, I told you already have a list of students in the course class. You want to add a course. A student is going to enroll to another course, and then you want to add this to the list. In the student class, you have the similar thing. You already have the list of courses you take. What if you want to enroll in a course? Then you have to add a course to this list, right? This is called insertion. In algorithms language, you want to insert an element to an already existing data structure. In our case, it's a list of students or list of courses, right? How do we do this? How do you guys implement this in your quiz? Can someone mention like how did he do this? How did you add an element to your list? Yep. Yeah. You're talking about lab 5? This is lab, yeah. Yeah, so one way is if you have a linked list, which is the case in our lab, you iterate to go until the last element, and then you add after the last element, right? But this is just one way of doing it. Is there another way? Even those who didn't look into the lab yet, what did you do in quiz? Because in quiz, we had a very similar thing. It doesn't have to be a linked list to be able to insert something, yeah? Yeah. Good. So what he's, and this is what you did in quiz? Yeah. So what your friend here is saying is I already have an array, let's say the name of courses of a certain student. I want to add another course. Then what I have done is I created a new array which is equal to the size of the previous one plus 1 to accommodate for the new element. Copy everything from the old array to the new array, and then add the new one as well, right? That's a way of doing things, but you can see how complex is that, right? And this is one of the most important things when we discuss arrays versus linked lists. But you can see now we are discussing different ways of implementing an abstract operation, which is inserting an element to a list. How you do it? There are multiple ways of doing it. This is one way, this is another way. A third way would be instead of inserting at the end, you just insert at the beginning or insert at the middle, right? You have many ways of inserting an element to a certain list. This is an implementation, right? This is an implementation issue rather than an abstract type issue. Because you already have a list, you want to insert an element. How you do it? It's an implementation issue, right? So if you separate implementation from abstract data type, as a user, I'll be able to use your list, and you provide me with the interface for that, like insert element, for example. You write a method that is called insert element, and then you don't tell me how you do it. I don't need to care whether you create a new array or you like insert at the end or at the beginning. I don't need to care. I just give you my node, my element, my entry. You add it your own way, right? So as a user, you don't need to care about how the implementation is done for inserting an element, right? This is one benefit, and this is, we have said this like for 50 minutes last lecture, one benefit of separating the abstraction from the implementation, right? So let's continue next time.